Welcome to the Digital GreenTech Konferenz 2024. Welcome to our guests here at Neuen Mälzerei in Berlin, and a warm welcome to all the guests who are joining us online. If you are thinking, oops, that's Ladybug on stage, that could be well intentional. In times of crisis like that, when an elected president denies man-made climate change, even though we need to act now to save our life on this planet, I sometimes wish I had a little ladybug on my side. But I can promise you, we have something much better. Young scientists who are looking for solutions with their ideas and projects that are presented at this Digital Tech Conference here in Berlin. Let me introduce myself. My name is Julia Wissmann, not Ladybug. I've just dressed like a Ladybug. And I'm a science journalist, currently hosting the podcast Science and Politics in Conversation, Wissenschaft und Politik im Gespräch, from the Research Institute for Sustainability, Helmholtz Center Potsdam. And the idea of this podcast is quite easy. Scientists are talking with politicians about the challenges of our time and discuss solution approaches. Digitalization and sustainability, the decarbonization of heavy industry and the building sector, measures to promote biodiversity, mobility, democracy, and sustainability are the main issues of this project. This conference goes even further. There is not just talk, but action. We will present research projects that intend to find concrete solutions for our environmental issues. With new digital approaches and processes, each project intends to improve economic efficiency and sustainability of environmental technologies. These 14 research projects we want to present today from the Federal Ministry of Education and Research, funding measures, Digital GreenTech, environmental technology meets digitalization, will present their current research status and ideas. These include projects from the field of water management, sustainable land management, resource efficiency, and the circular economy. Many thanks to the Federal Ministry of Education and Research for the implementation of the conference and the support of these projects. And a special highlight, I have to announce for the first time the Digital Green Talent Awards ceremony will take place at the Digital Green Tech Conference tomorrow at 1 p.m. You are invited to network and to exchange your ideas here. And now, please welcome Dr. Rainer Müssner from the Federal Ministry of Education and Research. Welcome with a warm applause.
Thank you very much for your nice introduction, Mrs. Ladybug, aka Mrs. Wissmann. Good morning, everybody. As you can easily see, I'm not dressed like a ladybug, but just like a boring science administrative, so don't worry about it. It's my great pleasure this morning to welcome you all on behalf of BMBF to this Green Tech Status Conference. And the right buzzwords have already been mentioned. This is an event to exchange, to discuss, to learn from each other, and to have fun between all those that are interested in digitization on the one side and sustainability on the other side. Even so, as you might have expected, being a representative of a German Ministry for Education and Research, I have two important messages before we come to the fun part of this event I want to share with you. My name is Rainer Müssner, and I'm working in the Division for Resources, Circular Economy and Geoscience at BMBF, and our division is responsible for this funding initiative, Digital GreenTech, as well as for the talent competition that has been mentioned by Mrs. Wissmann, where we will have the award ceremonies tomorrow. But let's start with the first slide. That's not the first one that has content. So is anybody moving the slides? Ah, this one. Strange technology. So what I like to share with you are two important messages. The first one is why we are here. Because contrary to what most people think, funding lines and funding initiatives are not dropping down like rain from the sky and are not the result of a bottom-up process. The funding of BMBF and your projects are embedded in a research policy. The three most important research policy frameworks for this initiative is the so-called Strategy for Research and Innovation for the Future. This is a research strategy not only from BMBF. Oh, I have to stay here, I see, clear. I'm always moving around on the floor. This is a research strategy not only from BMBF, this is a research strategy from the whole government. I know it's very difficult to speak about the German government at that time, but even so, for the time being, the so-called future strategy of the German government still exists. We don't know how long our government exists, what's the next government, and I don't want to elaborate on this, but this strategy is a political framework for your projects that you will present tomorrow. Secondly, a very important strategy that has a long legacy by now is the so-called BMBF strategy Forschung für Nachhaltigkeit, Research for Sustainability. Under this umbrella, you will find climate research, biodiversity research, green tech research like this one, energy research, and socioeconomic systems. So it's a wide umbrella. And the last one, a little bit closer to what you are doing in the project, is the so-called BMBF Action Plan on sustainable, digital, and ecological. As you can see, these slides are not in English and German, but I'm quite confident you will understand it. To sum it up, my first message, from the perspective of BMBF, we don't go into the nitty-gritty details of each project. Our level, what we are looking for, is the program level. And the program level is that what is defined by these strategies, and these strategies are the result of the parliamentarian will. We get our money you're investing in your project, based on the parliamentarian decisions where to spend money. It's not that I'm sitting on my desk in Bonn and thinking all the day, oh, what could be the next funding line? What's the theme for the next call? It's vice versa. It's upside down. That's why when you're presenting your final results at the end of your project, please reflect also what's your contribution of your research to the aims of this strategy. A little timeline on, here's a pointer, yeah, where we are. This is called the Status Conference and the Kickoff Conference we had in 2021. The so-called BMBF Action Plan on Sustainability and Digitization started in 2019. And this funding initiative in 2020, the projects in 2021. So your projects have already passed more than half of the project life cycle, and we are exactly here 1 to 18 months before the final conference. Why is this important? And now the second message, because BMBF has specific expectations regarding your projects and these programs. And these expectations go far beyond on teaching master students, PhDs, and maybe do a Nature publication or another publication. Our expectations regarding your projects are on the side of applied research and impact. A little sideline, if you have the pleasure to share an elevator with somebody from BMBF, may it be the minister or a state secretary. You know the famous elevator pitch. As a researcher, never tell a policymaker what you're doing. Never, never. Because he's not interested what you're doing. He's only interested in what is the impact of what you're doing. So you're not talking about, I'm defining a new software to increase the efficiency of water reuse. Your statement should be, when you're with a minister in the elevator, your statement should be, my work will will increase the efficiency of the water suppliers of Germany by 30%. That's something a politician can transfer to the voters, to the wider society. But don't tell them what you're doing. Tell them what's the impact. That's why, for the last 18 months, our expectations from BMBF to your projects is start implementing now. Of course, you can do still research, but you should focus your mind on what could be the impact of my research project. To whom do I have to talk? What are the concrete, very concrete results? Is it a device? Is it a software? Is it a new tool? And last but not least, don't underestimate the market. Keep in mind what could be the future clients of your results of your project. Who will pay finally money to use your result? It's a very important issue, and you should focus on this in the last part of this project. So, Kernfragen for our international guest means key questions. So what can your project in digitization of sustainability do to reduce the threat to the environment, to reduce emissions, and what can your project do to make processes, industry processes, processes in administration more efficient and more sustainable? And what has been achieved concretely in your project? Don't waste your time to make it perfect, even better. Stop making it perfect, bring it to the ground, discuss it with potential clients. So that's my main second message I'd like to convey to you this morning. I'm looking very much forward today and tomorrow morning with an exchange with you. I'm really curious what I can expect in the next hours, presentations, and of course the coffee talks. Coffee talks are always important. So I wish you all and myself, all our guests, great 2 days, today and tomorrow, and see you later. Have fun, and I give back to our ladybug.
Thank you very much. Thank you for the details, and I think that's really a very good tip to tell about, not about what you are doing, but about the impact of what you are doing. That's important because we don't have very much time to solve our problems. So we are certainly facing major challenges, global warming, the loss of biodiversity, or the finite nature of resources. Economy and society are increasingly becoming areas of tension, I know as a science journalist. The development of intelligent environmental technologies and resource-saving processes must be promoted. The decarbonization of industry or the building sector needs digitalization to succeed, but it is important that digitalization and the sustainable development are considered and implemented together. The digitalization has to be sustainable in itself. So how can artificial intelligence support this sustainable transformation? To answer this question, I am honored to introduce you to a great expert in the field of computer science and AI. She has been working intensively on artificial intelligence and information modeling for more than 15 years. Her current research interests are in the areas of AI for sustainability, sustainable AI, data modeling for the circular economy, including the digital product passport and the use of AI in the circular economy. Please welcome with me together our keynote speaker, Dr. Christiane Ploschniak from the German Research Center for Artificial Intelligence.
Hello everybody, can you hear me? Great, that's my slide, but this is the presenter, okay. Let me try. Yeah, it works, great. Okay, thanks for the introduction. Let me take you on a little journey to explore the relationships between artificial intelligence and sustainability. We will see that it's quite a complex relationship, and we have to keep many things in mind. But at first, a little introduction to myself. You can obviously see there's a photo of me. You might be wondering, who's that person in the upper right corner? It's not a picture of my grandfather, but we are indeed related. We come from the same place, actually. I was born in Chemnitz in Saxony, and that's where Hans Carl von Carlowitz invented or coined the term sustainability back in the 1700s. What did he do? He was actually a forest administrative, so he worked in forestry, right? And in the 1700s, they were mining ore in the Erzgebirge mountains, and they needed a lot, and if I say a lot, then I mean they needed really a lot of wood for that. And they were beginning to see that actually they took more wood than could be regrown, right? So that was the first time that they saw we need to change something. And he wrote a book about sustainable forestry, and that's actually the first piece of work about sustainability in the history of mankind. So he's from the same city, but it's just a coincidence. So, or maybe not. I'm not sure. Maybe it was my destiny, right? So I was born there. I studied computer science and German at the Technical University of Chemnitz. Then I got my PhD from the University of Rostock in computer science, and then I joined DFKI in Kaiserslautern in 2015. DFKI, as I will briefly explain later, is a research center that is focused on artificial intelligence, and there I'm very much concerned with sustainable production, circular economy, also the aspect of green AI, so how to make AI green, and I'm also a founding member of the DFKI ethics team, so I'm also concerned with the topic of AI and ethics. So to DFKI, that is the world's largest non-commercial AI research institute. If you didn't know, we have something like that in Germany. So actually there's, of course, bigger research institutes, but they are corporate, right? So we have the biggest one here that's non-corporate in Germany. And as you can see, we are spread out around different locations in Germany. I come from this side here, Kaiserslautern, which is very much in the southwest of Germany. Yeah, and we have several different more, yeah. What we also have there at DFKI is a competence center for environment and sustainability. So I'm not the only person working on topics like that in DFKI. There's actually even a few more colleagues from DFKI here. Could you raise a hand, everyone from DFKI? So you can see we have a few colleagues here that are also working on similar topics, and people that are interested in the intersection of AI and sustainability, they can join forces in this competence center, DFKI for Planet, where we organize exchange among the researchers, but we also talk to the broader public, right? So we write publications, we give talks, we organize exchange in many different ways, and that's pretty much a meeting space for us, but also for more people, and it's going quite well, yeah. So let's first define the key concepts that we're going to use. Maybe I'm boring you, but I like to have them a little bit clear. So you probably all know what is artificial intelligence. in a way, but it's important to define it. Although at DFKI we don't have a uniform definition. That's interesting, but everyone likes to have their own definition. The one I like most is the one from Anna Jobin from 2019, and she said it's the theory and development of computer systems able to perform tasks that normally require human intelligence. So that kind of keeps out this intelligence thing or intelligent machine thing a little bit. It just has to look intelligent, right? It doesn't have to be intelligent. It just has to do things that look intelligent because usually people do them and then they need intelligence for that. So that's my definition for this talk. And then sustainability, what is that? It's a principle of action for the use of resources in which a lasting satisfaction of needs is to be ensured by preserving the natural regenerative capacity of the systems involved. So what we have here is we only take so many resources to make it last, right? So that we can somehow pursue this further, that we don't run out of resources because we can regenerate. So you probably all know this three-pillar model. You're familiar with that. So we could say sustainability involves society, the economy, and nature, right? And all of these need to be in a sustainable state yeah, that's better, thanks. Need to be in a sustainable state to make things work, right? Then after that was developed the priority model that says there's no economy without a functioning society, and this one in terms needs a sustainable nature as well. And then comes my favorite model that was, I think it's about 10, 15 years old. That's the donut model. Who of you has seen the donut? Okay, there's a few. So actually the donut says that we have something like a social foundation, right? And we have an ecological ceiling to our economy. Keep this in mind. We have an ecological ceiling. If we use too many resources, we get problems with ecology. But if we use too little, we also get problems. But we get social problems. For example, people will not have enough energy. They will be hungry. They will need water and so on. So we need to somehow, you want to stay in this donut, right? You want to keep your economy inside this donut. And if we think back about our friend Hans Karl, he actually experienced the ecological ceiling for the first time. He didn't think about the social foundation back then, but the ecological ceiling he was experiencing. But we need to think about both. And then, you probably know all the Sustainable Development Goals from the UN. Everyone has seen those colorful pictures. And actually, if we implement all those Sustainable Development Goals, let's say we succeed, right? Then we will be inside the donut. So they made the Sustainable Development Goals to be inside the donut. So it's kind of a breakdown of this donut thing into concrete goals. So now to the question of the relationship between artificial intelligence and the Sustainable Development Goals. Is artificial intelligence good for the Sustainable Development Goals, or is it not good? To be honest with you, it's not so easy. You can see here on the left the positive impacts on the Sustainable Development Goals. And here you can see that some goals will benefit from artificial intelligence, right? So for example, the goal no poverty can be reached using artificial intelligence if we do it cleverly. Also for quality education and stuff like life below water, life on land, and so on. But, of course, artificial intelligence consumes resources as well. So here we have the negative side. If we don't implement this carefully, we can make things even worse, right? So the goal no poverty, which is interestingly also on the positive side, can be negatively impacted if we're not careful. Also quality education and stuff like that. Also reduced inequalities. If people have access to AI in rich countries and people in poor countries don't, we will have more inequalities in the end, which we don't want, obviously. So there's two perspectives on AI and sustainability. One is, how can we use AI to bring sustainability forward? So I'm going to show you some projects that we have at DFKI for that, and we will, of course, see a lot of them more during those 2 days. I mean, not every project is concerned with artificial intelligence here, but some are, right? And then there's this other perspective, the sustainability of AI, and we need to look at this also. So AI for sustainability, what can we use it for? We can use it, for example, to monitor ecosystems, to foster climate protection, to bring forward the circular economy and improve resource efficiency for the agriculture and food production, or for the energy transition. So I'm going to introduce 2 projects that we had at DFKI briefly. One is actually one of my projects has been. It's not running anymore, but what we did here is deploy something called a digital lifecycle passport. That's actually a digital product passport implementation in order to bring the circular economy forward. So the idea was that everyone in this life cycle of product can contribute information to that and can also use information from that. And with that, we can improve, for example, the product design, because the product designer will know what is sustainable and what's not sustainable. Or we can support the sorting of trash in the end of life, which is what we actually did in the use case. Yeah. We had a sorting machine, and then we had an AI-based object detection with multiple sensors. And then we fused that information with information from the digital product passport. And in the end, we could show that you can sort your trash better with this combined approach. What we also had in the monitoring field is to detect pollution in rivers and ocean, right? So because, as you probably know, most of the plastic in oceans comes from a few Southeast Asian rivers. So there's a lot of need to act upon that. And what we did here was take footage from that and detect where is the trash. You can see that here, the gray boxes, and also what kinds of trash we have here. So now the next perspective, the sustainability of AI. You probably all know that AI in the last years has become a lot more mainstream than before, right? We have all those deep learning models. We have image generation, we have chatbots, for example, ChatGPT. We have the recommender systems that we use every day, but all of this consumes energy. We can assume that training the GPT-4 consumed as much energy as 30,000 German households in a year. Let that sink in, that's a little town, right? It's only for one model. And there's also an estimation that operating the ChatGPT in 2027 could consume as much energy as a country like Sweden or the Netherlands. So that's also a lot. And then cloud computing also produces already more emissions than commercial aviation. I mean, not all of AI is cloud computing, but mostly they're related. So that's only for the energy part. And the big companies, they are not very transparent with the energy usage of their models. But we need to think about the resources required for the producing and running of the hardware as well. And that's, first of all, the hardware where the AI runs on. But then all those billions of end devices that people have to access those models and to access those services. So we need to make that transparent as well, right? And the problem here is that we have complex supply chains. Maybe the digital product passport can help to track those resources in the future. That's my hope. I'm also working on that. But at the moment, we have not come so far. Of course, there's also technical means to reduce the energy consumption of AI. Yeah? I'm not going to go into details of that. If you're familiar with AI, you probably have seen all those methods like compression, pruning, distillation, and transfer learning. Basically, they are all either reducing the model size or the training time. And this, in turn, reduces the energy consumption of such a model. So in the end, we get, hopefully, more energy-efficient models. What we have in DFKI is, for example, the Cascade project, where we do two things. One is to develop a framework for measuring the sustainability of AI systems, so to make this sustainability thing transparent in the first place. And then second, we use neuromorphic chip technology to improve the efficiency. So preliminary results suggest that we can improve that by 50% during training and up to 80% during inference, which is quite a lot. Another project that we have is a SustainML. This makes the power-aware applications more easy to develop for the developers, right? In the end, we want to reduce the CO2 footprint, but we must also make this more easy for the developers. How do we do that? For example, we develop pre-trained cores that people can reuse, so they don't have to start from scratch every time. So that's one thing. And in the end, this avoids so-called AI waste. Yeah? So to step one step back, what do we actually want and what do we need? Do we need always the most accurate model? Do we always need the biggest model? Just look at this graph of how many parameters we have for each of the big language models, right? It started small, but it increased exponentially. And with ChatGPT-4, we are very, very high. So the next ChatGPT, is it going to use even more? Think about that. Do we need it? And the question is, what is the gain in accuracy that we can have by adding more and more parameters and making the models bigger? Do we need to frequently retrain the models, right? Normally they are retrained if they become less accurate, but maybe we need to think about when is the point to retrain, right? And then another point, the kind of application we have. Are we using it to extract oil from the ground? Then it's probably not going to be sustainable, even if we use sustainable AI technology, right? So we have to think about what purpose do we have, okay? And then in the end, as I already pointed out, energy consumption is pretty bad, but it's not the only factor. Yeah, we have different others like land use or resource depletion too that we have to consider. So we would need to do a full life cycle analysis to finally cover the whole picture, right? So what I want to advocate for, we need a paradigm shift. We cannot focus on performance only anymore. We need to take sustainability into account as well. So if we combine those two, then we get sufficiency. And this is what we should strive for. Sufficient AI models that are pretty suited for the task that we want to use them for. So to conclude, as I hopefully have shown, AI has a really big potential to bring sustainability forward, right? We can use it for the monitoring of ecosystems, for circular economy, and so on and so forth. You name it. But we need to consider the environmental impacts of AI itself, right? And we need to have a societal debate. Where should we employ AI? What should we use it for? And maybe in which use cases some other technology could be more useful. So we need a paradigm shift. To combat the rebound effects, we need to come from efficiency to sufficiency. And all of that without compromising the individual and societal freedom. So that's a big task, and hopefully you can join us to achieve this task, right? So now I have one last take-home message. You can forget everything that I said, but take this one home with you. If we want a truly green future, AI must become part of the solution and not part of the problem. And with that, I thank you for listening. And I'm happy to answer questions, of course.
Yes, thank you very much. That was really a great, brief introduction to AI and the challenges and the problems and the chances. So please ask questions. Take your chance. We have a microphone for you. Probably you think about your questions. I have one question because you mentioned the digital product passport. What's the status of the digital product passport in EU at the moment, and how can we bring it to a success?
Yeah, well, the first regulations have been developed, but there's not really a clear plan on how to actually implement that. So there's a lot more research needed on that, obviously, to make this interoperable. So we have a concept that we are following at DFKI, but others are also working on that, and we need to somehow see what's good and what's not good, what works in practice, and get the industry on board, just to make this, in the end, a tool that really helps the economy to become circular, and not just one more like Berichtspflicht, right, where you have to submit your reports, and it's more a burden for the companies. That's what we don't want. We want to make life easier for them.
Okay, but you think we need more regulation for a sustainable
I think
economy?
at the moment we have enough regulation, but we need to kind of make this work, right? We kind of need to put this into practice, and there we need lots of stakeholders. We need to have companies that are willing to go forward and try this, to make to see what works and what doesn't, right? So because it's really a multi-stakeholder problem.
So, are there any questions? Yes, please. Here's a microphone. Oh, there. The microphone is coming.
Thank you so much for your inspiring talk. I especially like your idea of a sufficient AI model. Can you a bit elaborate more on how to achieve this ambitious goal? Because at the moment it's going exactly in the opposite direction. New power plants are being erected, coal-based, nuclear-based, whatsoever, you name it. What is the first step in order to be more sufficient?
The first step, I would say, in order to... thanks for the question, of course, that's really a good question. The first step, if you ask me, would be to make the resource consumption transparent, right? Because at the moment we have lots of problems to really... that's what I said. We have estimates, how much energy was consumed and how many parameters it has, but we don't really know because the big companies, they don't disclose. So I would say the things we have in hand, right? So the models we develop, we should try to make this as transparent as possible. I mean, there are libraries that you can use to make the energy consumption transparent and everything. But as I said, then it's only energy. And then you don't have all the other resources that are being consumed as well. So we need to track the supply chains and stuff like that. So to give people really a number. If you're using this AI service, it consumes this and that. So they can choose, right? They can make a decision. But first of all, we need transparency.
More and knowledge, transparency and knowledge about it.
Sure, yeah.
Are there more questions? No? Then I have one last question. As my superhero is a little bit Ladybug, yours is Hans Karlowitz.
Yes.
If he would be here, which question or would you ask him?
I think I would actually ask him what he thinks about the societal dimension, because obviously he didn't see that. He didn't have the need, but even back then they had these the ethical questions of who works in the mines and so on. So that's things that we, from today's perspective, that is normal for us to think about. But I would like to ask him if he also had this in mind, or if sustainability for him was, in the end, motivated by economy, because that's what they needed, the wood, right? So they had to somehow do something about this resource usage, but it wasn't the case that they wanted to keep the forest nice and clean and green. That was, or maybe it was, but he didn't write it down. But that would be an interesting question.
So a conversation between the two of you would be really interesting in the nowadays. Yeah, we ask AI.
Yeah,
probably
maybe
it's possible.
We can build an AI, Hans Karl.
Yes. So thank you very much for your inspiring answers and inspiring talk. Dr. Christine Plotznik will be with us tomorrow also, and so there's opportunity to network and to ask and to think together and to discuss. Thank you very much. So. So now we come to our first session on digital approaches for monitoring and surveillance in environmental technology. So please welcome Saskia Ziemann from the project management agency Karlsruhe. With a big applause. I would like to introduce you. You studied environmental sciences at University of Karlsruhe, now Karlsruhe Institute of Technology. Your research fields comprise issues of sustainability assessments, critical raw materials for key technologies with a focus on electrochemical storage systems, material flow analysis, and life cycle assessments. The topic of your doctorate is very interesting, therefore I mentioned it at the Technical University Darmstadt, was the investigation and evaluation of raw material availability for electromobility. And since 2016, you are working for the project management agency Karlsruhe, where you manage the BMBF research-focused plastic in the environment, where we met before. And now you are part of the Digital GreenTech team. So welcome, and the stage is yours.
Thank you. What awaits us is that we have some interesting projects that will show how the scientists use various digitalization methods to make processes smarter, more precise, and more efficient, thus enabling improvements in environmental monitoring and risk management of critical infrastructures. And before we start with the current projects, we want to take a look back on how our research initiative, Digital GreenTech, developed so far. So when the first call was released in 2020, the following goals were mentioned. It's about linking digital technologies with environmental technologies. We wanted to use digitalization potentials to increase sustainability and also save natural resources and reduce environmental pollution. Now we have already 2 funding periods, 27 joint research projects so far, with a total funding volume of approximately 30 million. And our great accompanying project, NetDGT, that are responsible for organizing all the conferences, all the successful conferences we already had during the last years. Now, what awaits us is the new robotic call that was released 3 months ago. It closed last Friday, and there the goal is to reduce environmental pollution, contribute to climate protection, and the United Nations sustainability goals through intelligent robotics. So we placed the robot in the center of the research for environmental technology. And the funding topics focus on research and develop new approaches for AI-based robotics and new possibilities for using intelligent robotics in environmental technology. And I think the projects will start next year. And we will get a closer look into this then in the next conference. What have we reached so far? We are funding, as I already said, 27 projects in 4 different application fields. There are 128 institutions that participate, and more than half of them are companies and practice partners. We have already completed 13 projects and now 14 ongoing that will be presented today and tomorrow. We have published 6 white papers, or the Digital GreenTech team has published 6 white papers, and also recorded 9 podcasts. Everything of this is available on the homepage. And we realized a children's book about digital twins, and I hope if you are interested, you can get some. In the first call, we already had 3 projects that were dealing with environmental monitoring. And in the second call, we have 5. And these projects will now be presented in more detail than this little picture can reveal. The first project we hear about is dedicated to digital dike monitoring, and it for disaster prevention, and it will be presented by Professor Holger Schüttrumpf. He will give us some insights on this project. He is a civil engineer with a doctorate in hydraulic engineering and now professor at the Institute of Hydraulic Engineering and Water Resources Management at the RWTH Aachen. There he is also head of the research group Coasts and Flood, with a focus on flood protection and risk management. Mr. Schüttrumpf?
Dann bleibe ich hier zumindest stehen. Okay, thank you very much for your kind introduction, Ms. Seemann. And yeah, it's my pleasure to present here our joint project Digitaler Deichläufer, or dike monitoring. And I hope this works. And yeah, I would like to bring you back to the beginning of this year or end of last year. You remember we had from our side, a very nice flooding in northern Germany, especially areas like Northern Westphalia and Lower Saxony were concerned. And maybe you followed the news, there was a topic on the weak dikes, because we had a problem with dikes, and dikes are important for our safety. And if we think about our safety, what we should avoid is breaching of dikes, river dikes, sea dikes, or whatever. So dikes are very important to protect ourselves. The problem is we have no possibility to check what is inside the dike. And what we need is we need to speak to the dikes. We need a kind of possibility to communicate with dikes. And that is not possible so far. So if I go back to the present way of dike monitoring, it's more like you have a person. The person goes along a dike stretch, and some dike stretches have a length of 10 kilometer, 20 kilometer, even more, which means this person has no possibility to be at all points at the same time, and the person has no possibility to check what is inside the dike. And that is strange, because if you, for example, go to a medicine, he will try to make some maybe ultrasonic soundings, and he will find what is the problem with you. And that is not possible with a dike. So by using something like a digital Deichläufer, we have the possibility to check what is inside, which means we can detect problems in dikes as soon as possible, but we can also identify those sections where we have to do something. And that will, at the end, help us to reduce all kinds of damages, including fatalities, which might be also a problem of large floodings. For example, if you remember the large flooding in the Ahr Valley in 2021. And that is why we need the Deichläufer, because we need this insight into the dike. Okay, I would like to focus a little bit on the current activities within the project. And what we need is to ensure that we are able to check what is inside the dike, we have to develop a new system. And this system should allow us to have this look into the dike. And that will be done by a kind of drone survey, including a GPR radar. But the problem is we don't know what we get as data. We are not able to interpret this data. We are not able at the moment to tell what is the result. And that is why we have to train our models, why we need as much data as possible. And then on the basis of trained models, we can use this system for real floods in the future. And that is the idea behind. Okay, we have different methods within our project. So one project is we have an experimental dike. We have a prototype dike in our laboratory. And this prototype dike allows us to install different kind of singularities. And the task to our colleagues with the radar system is to detect these singularities. And when we have trained the radar system on the basis of the singularities here in the laboratory, we can try to find similar singularities in the field later on. That is the idea behind. But we do also other trainings. So for example, we installed what we call the sandbox. Because in the sandbox, we can install quite easy different kind of weak points. And the task to the colleagues who train the GPR system is to identify these singularities. But we have been already in the field. We have a very nice dike stretch along the River Rhine. It's a lower Rhine. It's one of the largest and highest dikes we have in Germany. It's also one of the most important dikes. And we have the possibility, or we had the possibility, together with our partners from Practice, to check this dike and to get more data also related to training of our models. So just a short summary of what we have done so far. So we collected many data, both in laboratory and in the field. The GPR shows very promising results so far, but what we need for the remaining time is we need also a very detailed interpretation and integration of data in the geophysical model, and we need a BIM model, and then the whole system can be applied for future floodings to save people and to reduce damages. Thank you very much.
Thank you, Professor Schüttrumpf. We will start with the next, and then we have a common discussion at the end of the session. Now, Dr. Gabriele Packhoff will give us some insights into the DIVA project that focuses on digital, networked and interactive water quality monitoring. Mrs. Packhoff has a background in biology and a doctorate in limnology. And now she is a research coordinator at the Warnbach Talsperrenverband with a huge experience of about 24 years in this area. Mrs. Packhoff.
Thank you very much for the nice introduction. Yeah, so objective of our project was already mentioned. We want to develop an innovative and autonomous early warning system for water quality by digitally networking sensor systems and analyze the data with the help of artificial intelligence. The investigations focus mainly on the Warnbach Reservoir, a drinking water reservoir in North Rhine-Westphalia, but comparative measurements will be taken at the River Oder to see and test if our concept is transferable. Well, our activities in this year included a lot of field work. There was installation of the different sensor systems and also various sampling and measuring campaigns from May to October. We had to face some technical problems with our profiling probes, but hopefully these systems will work again in 25. Within the next days, the camera-based discharge and water quality monitoring system will be installed at the Warnbach gorging station. Well, here I want to show you 2 examples of data sets and results from our sensor systems in the Warnbach reservoir. We have 2 ADCPs that are acoustic Doppler current profilers installed at the reservoir, and you see here at the shallower water area there are higher current velocities compared to the deeper water. These are important informations for the modeling of transport processes, for example, the spreading of phytoplankton. The FICO probe, das ist ja. The FICO probe, an algae sensor, delivers high-resolution data of the phytoplankton in the reservoir. Every 15 minutes, data set is produced, and we can clearly see here the spring and early summer development in the reservoir. Next year, this probe will also be a profiling one, so then we do not only have data about time, but also about depth. Here we have for the automatic detection of Prymnesium parvum, the toxic algae that caused the fish kill in the river Oder was successfully implemented also in an algae sensor system. You see here the fingerprint that consists of a matrix of the excitation wavelengths and the intensity of the fluorescence of the different algae groups. And there were long-term measurements done at a water quality station, at a monitoring station at the river Oder, and there was no Prymnesium parvum detected, but this was in accordance with microscopic countings, but comparative measurements at other locations showed that the system works because Prymnesium parvum was detected and also in accordance with classical microscopic countings. The so-called Coliminder is a device, an online device for raw water monitoring at the reservoir. It detects the alkaline phosphatase as a measure for general bacterial activity. This runs since June this year at the Warnbach reservoir, and next year we plan to test it with specific enzyme activity to detect E. coli or enterococci as indicators for fecal contamination. For the molecular monitoring of cyanobacteria, a quantitative PCR assay was established, first tested with lab cultures and also now with real samples. And we are now in the phase to compare these data with our probe data and with microscopy data. This slide shows a time series of data from the satellite Sentinel-2. The data were processed to calculate water quality parameters like turbidity or chlorophyll A as a sum parameter for phytoplankton. And from left to right, we see a fading of a phytoplankton bloom within 5 days in the reservoir. And the graph underneath shows time series over a couple of years. And you see the blue marks belong to the higher values belong to the eutrophic pre-reservoir, and the red marks belong to the main reservoir, which is oligotrophic and therefore shows only lower values. Continuously, the data from the satellite are processed and compared with in situ and lab measurements. A database was set up for the project. The SQL database collects all the data from measuring devices, but also laboratory analysis and historical data. Some of the data processes are already done online and fully automatically. Some still have to be collected manually, but we are hoping to improve this. A dashboard was also created where some of the measuring devices can already be mapped, and soon this will be available to our project partners. And last but not least, a few words to the data analysis and forecast. We have selected Keras to create and train the neural network. And we see here an example for a first test run with a data set from the Warnbach, the inflow to the reservoir. The parameter chloride was coupled with various hydrological data, for example, precipitation. And you see the red line, which is the training and learning phase of the neural net. And the gray area shows the forecast ensemble. And the blue line are the real measured data. So we are quite satisfied with the results, and going to try more parameters and modeling in the near future. Well, with this, I want to end my not so short, maybe, introduction in the status of our project, and I apologize for any time overrun.
Thank you. Now we turn to a topic important to everyone traveling by train, for example. I think most of you did this to come here to Berlin. Since it deals with the risk management of, for example, critical infrastructures. The project IMON 5.0 focuses on monitoring gravitational mass movements and will be presented by Professor Daniel Zerwonka-Schröder. He studied surveying and geoinformatics in Mainz, completed his master thesis at DMT and his doctorate in Freiberg. Now he is a professor at Bochum University of Applied Sciences. Mr. Zerwonka-Schröder, we are curious to hear more from you.
Yeah, good afternoon, everybody. Thank you very much to be here to present our project. First of all, I would like to give a motivation, and I would give some points about our project objectives. And of course, as you already mentioned, the climate change is our motivator to do our project. And the climate change is changing the general conditions and has also a significant impact on the Earth's surface. And gravitational natural hazards like rockfalls, landslides, debris flows occurring more frequently. And such events are one of the greatest risks to human life and cause billions in damage to property and infrastructure and the environment. And they affect not only in Alpine regions like in Tyrol, in the Ötz Valley or in Switzerland. They also happens in regions in Germany like the Middle Rhine Valley in Kestadt in 2021, or at the Mosel River in Trier at the beginning of 2023. And in these areas, for example, what you mentioned already, the failure of railway lines, for example, due to these events leads to financial losses due to the closing of these railway lines. And for example, the Middle Rhine Valley is one of the most important railway lines in Europe between the Netherlands and Italy, Genoa. Yeah, and due to the climate change, the need for high quality 3D and 4D data of the Earth's surface is, or there is a demand for this data to increase a better understanding of the geomorphological processes behind these rock falls, what happens there. And our goal is to forecast these events, for example, with this big amount of data. And the data collection can take place on different spatial and temporal scales. And one example is a terrestrial laser scanner. With a terrestrial laser scanner, we are able to measure millions of points of the basis of one device position, a permanent installation, for example. You can see the points in this scheme. And in the last few years, these terrestrial laser scanners matured to communication sensors, programmable sensors, and due to this capabilities of these laser scanners, we are able to do installations permanently, automatically, and we can use these sensors remotely, for example. And this is for us the transition from normal, let's say, terrestrial laser scanning to PLS, permanent laser scanning. And this is the part of the data acquisition. And now a short movie. You can see our test site in Trier at the Mosel River. There was a first rockfall at the beginning of 2023, and the Geological Service of Rhineland-Palatinate said to us, let's do an installation there and monitor the rock phase in the next 2 years. And we did an installation at December 2023. You can see it here in a swimming pool area of the city of Trier. We have a webcam, a weather station, on the left side a laser scanner, on the right side a total station, inclination sensors, a lot of sensors on the rock face itself to have reference data for our to check our methods with the laser scanner and so on. Give me a second, sorry. So to meet the challenges related to the big amount of data, you could imagine due to permanent laser scanning. For example, we are doing scanning in Trier every hour. One scan has millions of points, and every hour scan 24 over 1 day, we have billion of points with data, but actually we need just one information. Is the rock stable or not? And not million of data information in this. And to face these challenges, we have to prepare new methods, like this method from the Technical University of Munich as one of our partners in this project. First, we have to check which are the stable areas and which are not the stable areas. A 0 or 1 decision. And in the next step, our colleagues from the Heidelberg University use these prepared data to do a discretization of the real world data, to voxelize the data, to have a fast decision which amount of rocks are moving or not. And if we know these areas, we do a change detection in detail on every point we measured with our terrestrial laser scanner. And for example, you can see it here. On the next slide, you will see for us, we had a lot of luck. In Trier, there was a new rockfall in August 2024, just a few weeks ago. And with our methods developed in the last year, we are able to detect this rockfall on the right side. And on the left side, we were also able to detect some fallen trees above the rock face, for example. Not that important for us, like the rockfall, but we were able to see that our methods are working very well. And here you can see another short introduction to this rockfall at the 26th of August. I received a phone call in the morning of this, it was a Monday morning, and they told me there was happened something, and a few minutes later we were able to do this presentation to the Geological Service of Rhineland-Palatinate. Yeah, and for us, it's a lot of luck, as I already mentioned. Of course, there were no damages to humans That's the most important thing, but for us, it's really good because we are able to see what happens before the rockfall, to check the parameters, which are the significant parameters to do forecast of these rockfalls in future. Thank you very much.
Thank you. Now, let's move from mountains to trees and take a closer look at the Tremon project, the first experience and results in acoustic tree monitoring. The person behind this project, and I think with kind of a great enthusiasm for trees, is Mrs. Antje Wilhelms. She is Managing Director at the IFU Private Institute for Environmental Analysis and has a background in business informatics as well as many years of experience in project management. Mrs. Wilhelms, the floor is yours.
Yeah, what if we could hear when a tree is stressed or has infestation? This is exactly what our project is about, to develop an acoustic emission sensor node for the condition monitoring of standing trees. Yeah, in the consortium we are 5 companies and 1 Fraunhofer Institute, all situated in Saxony. A few words about the project idea again. It is well known that various types of microacoustic sound emissions occur on and in trees, so-called dendroacoustics. Yeah, it's here. Up to now, the condition of trees has been assessed from the outside by experts. In worst case, undertaking invasive drill samples from the tree. That is time-consuming, it is costly, and it does not allow high-resolution long-term monitoring. In the project, we would like now to develop an autonomous sensor system that is able to objectively measure various aspects of the tree vitality, like thermomechanical stress due to wind and snow, for example, drought stress events, the sap flow situation, but also feeding noises from small animals. Such a sensor would raise the monitoring for city and street trees, but also in fruit growing and forestry to a new quality level. So what we achieved so far in concern to sensor development and data transmission. On the hardware side, we did a lot of investigations for measurement technologies. We did tests on laboratory scale. Here you can see some options how to attach the sensors to bark, bast, and sapwood. And the results show that measurements on the bast are most suitable, and there's no need to go down to the sapwood. In the area of communication, we developed the concept using LoRaWAN gateway, but to be honest, I don't want to go into more detail due to time constraints. With the knowledge we gained, the first trials began in April, May this year. We did measurements in the forest, as you can see here in Tarant, but also on city trees, and as you can see in the middle, under very strict observation, we did also on fruit trees. In order to evaluate the measured data, to evaluate the measured data and correlate it with the tree condition, we did comprehensive tree condition assessment using different methods. Visual conditions assessment, we did some multispectral recordings by drones, and also some vitality assessment using vegetation indices. The evaluation of the data from the test measurements has already brought many interesting findings, which will be presented now by Dr. Frank Schubert from Fraunhofer IKTS.
Yeah,
Hello, everybody. I would like to present some very interesting results of some of our test measurements. So first of all, here on the left top side, you can see a typical attachment of one of our piezoelectric microphones at the trunk of a tree. And you can see several results of our measurements. On the right here, we have a typical acoustic emission time signal of very fine and high frequency fiber cracks, so-called crackers, before a macroscopic branch break on a fruit tree was detected. And this is very typical and can be used as an early warning detector for these damages. This principle, by the way, is very similar to what we are doing in infrastructure monitoring in civil engineering structures, for example. You heard about the collapse of the bridge in Dresden, the Karola Bridge, and the remaining parts of the bridge are currently equipped with a similar acoustic emission system to prevent a further damage. Unfortunately, the collapse part was never equipped with such a system. Here on the bottom left, we have a drying experiment. You can see the number of acoustic emission events over time. And the starting point was a wet and a dry trunk of a fir tree. And here we can see a very typical, it's no longer working here, unfortunately, so I have to do it manually, I guess. Oh, okay. Here again. We have a very characteristic increase of the number of acoustic emission events during the phase of drought stress events. Then we have a maximum with a following decline of the number of acoustic emission events. And this is the phase of micro and macro cracking. And at the end, if we only have very large micro cracks, the acoustic emission activity goes down to nearly zero. And finally, we have an interesting measurement we performed in the field. It's a bark beetle measurements on different pine trees. Here again, we have the number of acoustic emission events over time, and we can see that at least for the more infected pine tree, we have a significant increase of the number of events. So if we listen to the spectrogram, unfortunately I cannot show it today now, but we can listen to the feeding noise of the bark beetles. That is very impressive. And for the other pine trees, which show a lower infection and no infection, the number of acoustic emission events is significantly smaller. So that was a very interesting result from the field. So to summarize our results after the first project year, so most of our test measurements in the lab and also in the field are successfully finished. At the moment, we were able to prove 3 of 4 relevant microacoustic effects coming directly from the tree. That is fiber breaks, feeding noises, and drought stress. The sap flow is still under consideration. We identified the typical frequency ranges of the measurements. This is relevant for the development of the sensor node in the following year. We additionally did optical multispectral measurements with flying drones and also tree condition assessments by human experts. And we need this in order to correlate the acoustic measurement data with with the results of these investigations. And this will serve the basis to create first training data sets for our evaluation, which will be based on machine learning. Thank you very much. If you're interested in more details, you're invited to come to our poster and discuss more aspects. Thank you very much.
Thank you. So, the best comes last, or better, this time the robots come last. So we will now hear and see the current state of Lalveco, the autonomous robot, the laser unit, and how to shoot at very small plants. Presented by Dr. Sebastian Pütz. He is a computer scientist with a doctorate in computer science, robotics, and AI. Everything. Since 2020, he works as a senior researcher at German Research Center for Artificial Intelligence and is also co-founder and CEO of Nature Robots. We are looking forward to your talk.
Yeah, thank you very much to be here. My name is Sebastian Pütz from the German Research Center, as you all know. I'm talking about LALWECO, long-term autonomous laser weed control. So we are shooting a bit like in Star Wars to small plants with lasers. And it's a consortium of 3 parties, like the DFKI in Lower Saxony and the Plant-Based Robot Control Group, led by former Joachim Herzberg, and now it's Martin Atzmüller. And then there is Nature Robots and also the Laserzentrum Hannover. And in the project we have mainly these working packages, so you see different types and challenges we had to master. For example, the work package 1 is laser unit, so the LZH builds a laser unit. And then we have the work package 2, for example, where we really need to acquire a lot of data and also create synthetic data, so fake data you can imagine. You will see later, and also in work package 3 you see the perception pipeline and also how to target a precise 3D point underneath the robot while driving over the beds of plants and also weeds. And work package 4 is integration, so bring all these things together, and in work package 5 we need to drive autonomously for a long time over all these fields and beds in a controlled environment first, which is like fenced, and later also in the next years, hopefully, also on normal fields. Let's deep dive into these work packages a bit more. So we planned the robot and also together with the laser unit integrated first. So in the project we just planned with 1 unit, but later we can also have multiple units next to each other to have a more track width of the robot, so that we have more wider robots and can process more area of a field, for example. And we actually did that then after a year. So we implemented the robot and also the laser weeding module itself, and the laser module is integrated. And you can imagine like why it's important, why shooting at plants, because 1/4 of the global CO2 emissions is generated in the food and farming sector. And like really by using laser weedings or no-till farming, it's about that we can save 2 tons per year per hectare. That's huge, that's massive, and that's why we are also doing this project. And you always hear comments like, okay, laser weeding, isn't that consuming a lot of energy? No, it's not. And here are the numbers. So at the end, we are consuming about 1.1 kilowatts. And that results in, with 2 laser modules, and 8.6 hours of autonomous operation in the field. And in another work package 2, we collected a lot of data in 16 beds in our controlled test environment, AI Market Garden, and a lot of like pictures and crop data and so on. And these data or these images look like that. So we took photos with the robot and manually of weeds and crops, and you can see what we really need to target with the laser is a point of vegetation, like where the leaves come out. That is really massive, and that's a massive challenge, because while driving, and that's a really tiny point in the real world, and then also in the pictures, you can imagine really high resolution images you need to process and then put into your deep learning pipeline for perception and then detecting this point while driving. So we have on the one side the robot collecting the data and controlling the laser unit. On the other side we have the storage of the images. We need to label the images automatically, but also having synthetic data and training that can be done on the cloud or on some computer. We took out really in the field some weeds and also plants and classified them, and we also had some unknown plants here because it's really challenging. And from these plants we then created synthetic data and we needed some semantics, so what type of plant is it? We needed the key point, so where to hit the plant, where is the vegetation point, where we need to orient the laser to. And we needed the instances itself, and then by that also the bounding boxes. And here you see then also some textures we can create to artificial data. And also later we can have some data where we just create random sizzles, for example, like here. And this data is then used because we know every pixel on the image belongs to a certain plant or not, and where the center of vegetation is. And these images are not real images, they are synthetic, so they are not real. And by that we trained our module. And here we used later a real image of our garden and used our pre-trained model and detect really, really nicely also the crops and the weeds. And if you really notice in detail, there are red dots, and these are the detected, perceived points of vegetation where we need to really shoot at with the laser to really weaken the weeds. We also integrated that in a way that we now can control the laser module by the robot operating system itself, and that's work right now. And the next step is really to connect this to the perception model and to the perception in the field, doing this while driving over the field. Some notice on the robot and its state. It's out there and it's running. You see that in the video. Here, for example, it's a mounting system where we can mount and demount the module itself. It's now driving over the beds autonomously. Some people from the LSH we work together with. And what is really important that the module is really in a rigid body with the whole robot, because if some things are really shaking or so, then it's even harder to really point some milliseconds on the weeds on the center of vegetation, and also correcting the orientation while driving. You can imagine, because the whole system is not like in a fixed position, but it's really dynamics and driving over the field. Yeah. Thank you very much. That's by the way the team, and happy to answer questions later.
Yeah, thank you. You can stay here, and I want to call the other speakers of this session back to stage for a joint discussion. The two of you? Okay. So, a lot of interesting talks and insights, and now you have a lot of questions, I think. Yeah, mutige vor.
Yes, hello. I have a question for the dike monitoring. You mentioned that you put DPR sensors on drones. What is your experience with that? How high can you fly, or how deep do you have to go, and how deep can you penetrate into the soil?
We can't fly very high. That is not the idea. But the problem of the dike is, in the case of the flooding, the dike can be indeed quite weak. So it's not safe to walk on the dike, which means we need the possibility to monitor processes inside the dike without walking on the dike, without driving on the dike. And one of the possibilities is to use a drone. But this means the drone should fly very, very deep, should not touch the dike, but we can't fly maybe 50 meter or 100 meter high. That is not possible, because then we won't get any signal. So the idea of the drone is just to fly over the dike and get some data. And then we will get data. We are interested in data. It's better like this, because we have a lot of light here. And then we need data, especially for the, let's say, first 1-2 meter inside the dike, because we know the different failure mechanisms of dikes, and we need to identify which might be a failure mechanism in the case of the flooding. And therefore, we just need to monitor more or less the surface minus something like 2 meters.
Thank you.
Hello, my name is Caroline Lange from KIT, and I have a question for the Almond team. I was wondering if you already have some experience, how early can you detect the rockfall? So how much time do we have to act until the rock really falls down? Thank you.
Yeah, thank you for your question. This is the big question, and this is the question we have to answer in the last year of our project, because this is the luck we have now with the rockfall happened, and we have all the data in front of the rockfall, and now we will have a look on it, how, which time we have to do an alarm, for example, but up to now, I'm not able to give you a good answer to the question.
Okay, still in progress.
So thank you very much for your very nice and interesting presentations. Indeed, very impressive results. I'm very happy to hear it. Actually, I have a question to all the 5 presenters, and you can choose what you want to say about it. When we talk about environmental monitoring or geomorphological hazard monitoring, quite often the responsibility to do the monitoring is not in the hand of the federal states, it's the authorities of the Bundesländer in many cases. And once or twice I had the pleasure to talk to the colleagues and ask them, why don't you use the new developed technologies, the options that AI and digital technologies offer you? And normally I get 3 answers. The first answer is, oh, that's very nice what your researchers developed, but it's too cost expensive compared to the standard. Second answer is, I get, oh, that's not the standard that I'm obliged to do my monitoring, environmental monitoring. It's not defined in the technical specificalities I have to follow. The third argument I get quite often, oh, that's very nice with this laser thing, but I don't have the people with the capacities to work with it. So these are the 3 standard arguments I hear when I ask about to implement or apply new technologies. What would be your specific answer if you're confronted with this perception of why people don't deploy or use your project ideas?
Who has an idea?
Is it true that your technology is more expensive than the current state?
Okay, let me start. So first of all, I can underline what you did, because that is indeed the case, but that is not everywhere. Because especially in the case of dikes, it depends also a little bit on the size of the dike board, for example. So, and that's why we have chosen a very big one at the Lower Rhine. So they have the capacities, they have the people, which makes it more attractive for them. And they have even drones, so they are used to fly drones. So they have the capacities, they have the expertise, they are much more qualified. We could have chosen also a very small one, but then indeed we would have the problems you mentioned. Second part is, of course, the economic aspect. I think it depends a little bit. For sure, a drone is expensive, but not as expensive. On the other hand, if I think about dikes along the River Rhines, where we have enough forecast time, if you have a special consultant who is able to do these tests, we don't need the expertise at each individual dike board. So, for example, flooding at the Rhine, we have a forecast time of something about 2 weeks, which is enough time to order someone who can do the tests. So we don't need the expertise in each individual dike board. That is different if you go to these very small rivers where we have low forecast times. If you think about what happened at the Eifel Mountains in 2021, we had forecast times of a few hours. Then it's not possible. But then even in that case, it doesn't make any sense to use these radar drones. So I think there is acceptance, and that's why we had easy possibilities to get acceptance from this dike board at the Lower Rhine. We see also acceptance at other water boards in North Rhine-Westphalia, for example, the Emscher Genossenschaft, but that means the interest is there where we have enough people, enough money, and enough capacities. Then it works, but not the real small ones.
Maybe answering this question in the direction of a market of autonomous robots and also perspective of startups in this area. So right now we are, I would say, in the right position. Like we have the AI Act in place, the new machine regulation is there. So we have all the laws, the direction we need to run. And also the market is estimated to be around 60 billion in worldwide in autonomous robots. And there are a couple of startups and companies also in the world, in America, which do laser weeding. So, but at the end, it needs to be not too expensive. Like you can imagine, much on the hectares, it needs to be less costs for the farmer, for the owner of the fields, than a normal tractor. But right now it's also a problem that the people are just missing, like the workforces are missing. That's a huge, tremendous lack of labor, not in Europe, not also only in Europe, but also in the US and other parts of the world. So it's a tremendous thing, and at the end, I think the technical readiness level, it's something like we will maybe end up at 6 or so in the project, and then there are 3 more to really make it a product and make it run robust and really in a way that farmers can easily use it. That's the main goal and thing.
I have some thoughts. I'm absolutely with you. I have the same experience. First of all, how much are the costs? And in our case, we have the installation in Trier around about 100,000 euros. And the first question is, okay, when we have 3, 4, 5 of these rock faces in Trier, we need 3, 4, 5 of these installations. This is too much. And I like the research projects from the BMBF very much because they are very application orientated, and we can have all these discussions on site. And now, for example, the next step is that we replace some sensors with low-cost sensors, and we will see what happens with low-cost. Are we able to achieve the same accuracy and these things? And we have this showcase in Trier and can say, okay, it's only 10% of the costs. Perfect. The second one regarding the standards. In my work, I always have a look on the current standards, that we can align new methods to the standards, and then we have a nice foundation for all these discussions. But the standard, for example, regarding the geomorphological monitoring in Trier, for example, is that there are 2 geologists from the geological service from the federal state, and they go in person to every rock face in the whole country and see what happens there. For example, in Trier, once, maybe 2 times a year, they will come to the rock face and see what happens. And then at our first meeting, they start to show or to see some photos on a smartphone. Last time, it seems it is stable. you could imagine it's not that accurate, and they are very open to use these new techniques regarding this higher to achieve this higher accuracy. And yeah, the last point, it's similar to the second point. They have not that much engineers and geologists, and they are very open to automatization, to do measurements remotely, and these things. This is my experience regarding this project.
Maybe some addition from my side. Our topic is tree assessment, and what makes tree assessment so expensive at the moment is the fact that it's done by human experts at the moment, and it's a very large effort for them to do it on a regular basis for all relevant trees. So I think even if the final sensor node we want to develop in the project will cost, let's say, a few hundred or maybe a few thousand euros, it can make sense because the regular use of human experts over a long time is even more expensive. So I think it's realistic that at the moment we think the system could be in extension or in addition to human expert opinions, but I think at least for selected trees, especially in urban areas like cities, parks and at streets, it could be really a benefit. And of course, we try to make it as easy as possible. That is something that also the project needs to show. What kind of data do we really need to make the final decision? Because the final decision is very simple. It's the tree is safe or it's not safe. It was similar to one of your projects where you say the rock is stable or not. But of course, at the moment, we are just in the phase where we want to find out how we can reach this final decision. And therefore, we have to collect a large amount of data, very detailed data, and see what is included in the data. But at the end, the final system should be very easy, and the final decision should be very easy. And then I think also the system could be cheaper.
Okay, thank you. Do you want something to add, or can we? Yes.
For the water quality monitoring, I think there are two aspects. The classical sampling needs a lot of personal capacity and also a lot of expertise, and we are lacking more and more the experts that can determine phytoplankton species and so on. So we need, I think, some new methods to give at least an oversight over the development of a lake. And the other thing is a high dynamic of water quality changes. We've seen that at the fish kill in the River Oder. Within days, we can experience such water quality changes, and we need some methods that can cope with these high dynamics of the water quality changes. And I think this is something for the satellite data, for online monitoring and so on.
Thank you. We had one more question, I think.
I was just thinking maybe it's a stupid idea, but this idea sprang to my mind since you said you are already using the acoustic tree monitoring on bridges. Why not monitor the rocks with this technology? Do you think it could be promising to apply this to the use case?
Yes, of course. Originally, these kind of methods stem from geophysical applications, so I'm pretty sure that there is a lot of work going on in this area. But maybe my colleague can answer this question.
Yeah, I could imagine that it will work, but the goal of our project is to do contactless measurements on the rock face, because maybe you could imagine if we have these dangerous areas. Often it's not possible to go to these areas. It's similar to the dikes if we have floods, for example. And therefore we are focusing on methods and sensors. Yeah, we can use the measurements from contactless.
So then you need a drone?
Yes, maybe. We did also some drone flights, and regarding the drone flights, we have some issues regarding the regulations. where to fly a drone, where not, and these things. It's, yeah, a lot of limits to keep in mind.
Thank you. Is there one more question? Yes.
Yeah, thank you for your presentations. I have a question for AI Moon, and maybe it also fits for the lake monitoring and tree monitoring. Do you also consider open source data, like available weather data in your models? I guess those have a lot of influence on your prediction. And what kind of additional data do you use? I guess you don't rely just on your sensor data of your installed measurements.
Yeah, thank you. We use it in both directions. On the one direction, we use input data, like from the DWD, the German weather service. They have open source data. They have also open source data from Trier, and we use this data. We also use data, I don't know the English word for das deutsche Schienenforschungszentrum, has a lot of data regarding slope stability over the whole area of Germany. And we have also keep in mind to use open source software like from the colleagues from Heidelberg to give you an access to our methods and our data after our project, for example. These are the two directions from our side, and yeah, we are very open-minded regarding this point.
Yeah, I think we will also use the data available for weather, from the weather data from the DWD, and for our project, we are very lucky that we have long data sets, historical data sets we can also use for training the neural network. So this is for for our lake monitoring.
In our case, for the tree monitoring, we will not use public data, but there will be additional sensors on board of the sensor node. So at least we will have a temperature sensor, maybe a wind sensor too. Humidity is not so important for acoustics, but temperature is definitely an issue. And also the wind is an important factor that, of course, may influence the number of acoustic emission events. So this will be an elementary part of the sensor node, but due to time constraints, I was not able to show it in our presentation.
You can use the time in the breaks to ask further. So, are there any more questions now? Okay, then a big thank you to all of the speakers. It was great to see how these ideas that were presented last year in Karlsruhe, how they developed and how they kind of now come to life. Thank you.
Thank you very much, Simon, for this inspiring presentation of the projects here. They're really far, aren't they?
Yes, of course.
Great. So you have time to ask more questions in the upcoming coffee break and to mingle and to network with the project projects and the people who present the projects. And I would like to inform you about the workshops we present after the coffee break. And please welcome Nicholas Becker here. You are one of the representatives of the workshops. So you can take also this microphone. There are two workshops after the coffee break. One is, let me see, about the Forschungsmanagement, so about the research management.
Research data management, yes.
You will, you will do it?
Yeah, so I don't need to use too many words, but just so that you have an idea, for the workshops we have prepared something fun and interactive.
That's good.
Yeah, we want to play games together with you. We have prepared 2 strategic games where you can learn something about resource allocation and distribution within a research project. So you will play a fictional research project. You should be somehow familiar with that role. And yeah, one workshop is focused on research data management and the other one is focused on AI. I think both will be very interesting. So my hope is that you can distribute more or less evenly across those 2 workshops. I think you would enjoy both of them. Yeah, so I think that's enough for the intro.
Yeah, but should we make a little test? Who's more interested in research data management and who's more interested in AI? So please give us a sign for research data management workshop. Okay. So, and the rest is interested in AI, I guess? Okay,
that looks
so
good.
That's kind of equal. Yeah. That's good. So one of the workshops is in the Kuppelsaal Nord and one is in the Kuppelsaal Süd after the coffee break. And yeah, we have a coffee break now and meet at 3:30 again for the workshops. So have fun and take a coffee and
see you at the workshops.
Okay, see you at the workshops. Thank you very much.